Hi. Welcome to the last lecture of the course. It's been a long time. This quarter, 9 weeks, feels sometimes like 9 months. You made it. Good job. It hasn't been easy for anybody. We just have a little bit more to go after this, and then you're done. So please continue to ask questions. I hope that everybody finishes the course strong and that things work out. So our last topic here. So, oops, that's not what I wanted to do. So I'm going to do that. Good. Let's go to the next slide. Okay. So here I just want to continue the story that we left off with, and we kind of came to a branch point. We were looking at the hormonal control of the female reproductive cycle, and we came to a branch point, and we went with no pregnancy in the lecture that just ended. And this lecture we're going to start with if the egg becomes fertilized when it's in the fallopian tube. What happens? How do we maintain the pregnancy? What's different? So this figure should look familiar. We've already gone through something similar to it. Ovulation, of course, occurs here. And the egg is released, and then it is fertilized. Okay. Now, continues to move through the fallopian tube as we talked before. Here is the morula. And I mentioned before that the morula is a solid ball of cells. And then it starts to hollow out later and becomes a blastocyst. And what they're showing in this figure is kind of interesting. I won't make a big to-do about it. But I got to looking at this and it talked about blastocysts hatching. And I go, what's going on there? Well, what happens is that up until this point, the egg has been bound by the zona pellucida. Well, it's going to start to grow. And up until this point, where we have this solid ball of cells, the morula, the overall diameter of the ovum has not changed. So the diameter here, if we measured that within the fallopian tube, it's essentially the same diameter as that we started out with. Which makes sense. It has to stay inside that fallopian tube, which is not much bigger than about 3 human hairs stacked together. It's incredibly narrow. There are cilia along the way that move the egg along, but it can't get larger or it will get stuck. So it stays within the zona pellucida. The cells just get smaller as they become more plentiful, but eventually it exits the fallopian tube, no longer constrained by the fallopian tube, and it has to grow larger, so it gets out of the zona pellucida. So it squeezes out of that, and that's all that's being shown here, hatching out of the zona pellucida. I'm not going to really test you on that, but I just think it's kind of interesting. The blastocyst then implants in the uterine lining. So this is the blastocyst. So we're going to talk about that a little bit. So here's an enlargement of a blastocyst. And a couple of things to note. This is while the zona pellucida is still on there, but there is an inner cell mass, which is sort of this. So these are the embryo has hollowed out, and here's a blastocele So this is a fluid-filled space. It's like an antrum, essentially is. And the inner cell mass, this is the part of the embryo that will develop into the fetus. That inner cell mass. The other part, sort of the wall, the surrounding cells, is the trophoblast. And the trophoblast is interesting. It's going to be producing a hormone, and we might as well go ahead and write that, or I'll at least abbreviate it, and we will talk about it in the next slide. It's going to produce the hormone HCG, which is human chorionic gonadotropin. So that's coming from the blastocyst. Now this is only 1 week after fertilization. So remember what's going on with the ovaries. So we have about 2 weeks post-ovulation before the corpus luteum quits functioning. And we still have to maintain this endometrium. And you remember who was stimulating the endometrium? What were the hormones? Primarily progesterone. And who is producing the progesterone? Corpus luteum. Okay, so let's go to the next slide. So, what do we have here? Well, let's just read the bullets first. The endometrium must be maintained mainly by progesterone. And so let's ignore the figure on the right for the moment. Let's look at the figure on the left and find the progesterone level. Well, it's the red line. It's going up. We've got about 2 weeks during this luteal phase. After which point the progesterone levels start to decline. And that's going to cause the endometrium to slough off, have menses, and the pregnancy won't work. So we have to maintain the progesterone. The trophoblast produces human chorionic gonadotropin. Now here's another gonadotropin. So what's going to be the target for a gonadotropin? It's going to target the ovaries, the other endocrine tissue. So it targets the corpus luteum in the ovary and prevents degeneration. It maintains the corpus luteum so that the corpus luteum can continue to produce progesterone primarily, maintaining the endometrium. It's also going to be producing estrogen, but it seems to be that progesterone is particularly necessary for maintaining the endometrium. Some women that have recurring miscarriages, one of the things to check for is the progesterone level. If it's inadequate, that may be the reason for the pregnancies being lost and spontaneously aborting. So that's an easy one to check. So the figure on the right is the picture of those 3 hormones. So HCG, human chorionic gonadotropin, there's fertilization, and fairly soon after, I don't know, looks like several weeks, maybe 3 weeks, HCG levels come on the scene pretty quickly. This is in the blood. It can be detected with pregnancy, can be detected with a blood sample. If you have HCG in the blood, there's no other place that that comes from other than a developing embryo. And remember who's making the HCG? It was the trophoblast. And the HCG stimulated the corpus luteum to continue making estrogen and, again, progesterone. And those levels continue to increase till about the time of birth. And then things just crash. So, that's the story of HCG. At some point, you remember how the kidneys work. The kidneys are filtering the blood, and if there aren't any specific transporters for recovery, for reabsorption, which there aren't for HCG then spills into the urine, and then when the levels of HCG are high enough in the urine, a home pregnancy test can detect that. So what happens after, well, the HCG levels deteriorate. They can only go on for so long. And what happens is the corpus luteum does eventually give up the ghost and quit producing, but the placenta takes over. So last bullet. Corpus luteum continues producing progesterone, maintains endometrium. Let's say for approximately the first trimester. Then you still need to be producing progesterone and estrogen, but the placenta takes over. Takes over producing progesterone and estrogen. Maintain the endometrium. Maintain the pregnancy. Okay, done. Happy Friday.